Hello, I'm Jeff Smank, an agronomist with the Palmer Soil and Water Conservation District. This video presents the results of a cover crop trial sponsored by the USDA Natural Resource Conservation Service, in which we wanted to see how late we could plant an oat, pea, buckwheat, radish mix and still get the anticipated soil health benefits. Although the agronomic benefits of cover cropping have been known for centuries, farmers are often reluctant to take expensive farmland out of production for a full season. So, for this project we wanted to determine how many weeks a cover crop had to be in place for the farmer to receive the expected soil improvement benefits. The approach for the project was to plant the same cover crop mixture, oats, field pea, buckwheat, and radish on a weekly interval from June through September. Then, after the killing frost terminates further growth, go in and measure a number of crop and soil attributes and see if the longer periods of cover crop growth corresponded with improved soil health measurements. The trial took place in the Springer Loop near Palmer, Alaska. The soil is a Bodenberg silt loam, the field was an irrigated vegetable field, and we inoculated it with both rhizobium and mycorrhizae at the time of planting. The farmer tilled the field in late spring. The soil was maintained weed-free right until it was planted. The plots were 30 foot by 50 foot, and the plots were rototilled on the day of planting. The seed was applied using a push-type seeder, and we were able to use the center pivot irrigation system 3 times during the growing season. The first plot was planted on June 9th, and a week later on the 16th the second plot was planted. A week later, on the 23rd, the third plot was planted, and this pattern continued all the way into September, with planting on a weekly basis. A killing frost came in mid-September, so we stopped planting. After further growth was stopped by the frost, we started measuring the various crop and soil parameters we were interested in. The plot that was planted on September 9th had 1 week of growth, and the plot that was planted in the beginning of June had 14 weeks of growth. Here's the plot that's 1 week old, 2 weeks, 3 weeks, 4 weeks, 5 weeks, 6 weeks, 7 weeks, all the way to 14 weeks of growth back by the truck. 1 week of growth, close up. 2 weeks of growth, close up. 3 weeks of growth, close up. 4 weeks of growth, close up. Unfortunately, by 4 weeks old, some of the weeds are already beginning to show. This one is pineapple weed. 5 weeks of growth, close up. 6 weeks of growth, close up. 7 weeks, close up. 8 weeks, close up. 9 weeks, close up. 10 weeks, close up. 11 weeks, close up. 12 weeks, close up. 13 weeks, close up. And the first plot that was planted back in early June, 14 weeks of growth, close up. And here's the control plot that wasn't planted. When you look at the graph of crop height, we see a logarithmic growth curve for the first 8 weeks after planting. At 9 weeks and beyond, the crop height maxed out at about 30 inches. We ran a sickle mower down the plots to harvest biomass. Similar to the crop height graph, we can see a logarithmic increase in biomass for the first 8 weeks of growth. After 7 weeks, almost all the plots had over 2 tons per acre of residue. We used the beaded string technique to estimate the percent ground cover. With that season's warm fall, we achieved adequate ground cover to minimize winter erosion after only 4 weeks of growth. In the subsequent cooler fall the following season, we needed 5 weeks of growth to get the same level of ground coverage. To determine bulk density, a measure of how compacted the soil is, a 4-inch section of 4x4 rectangular tubing was driven into the soil. It was carefully removed, trimmed flush with a knife, dried, and weighed. Bulk density is often quite variable, so the middle, or median, value of the 3 measurements from each plot was used, shown here as X. There was little difference in bulk density across the cover crop plots, and overall the median bulk densities were a bit higher than the control plot. These bulk density results make sense because the bare ground of the control plots had recently been rototilled for weed control, and tilling fluffs up the soil, lowering its bulk density. It's likely that the bulk density differences associated with cover crops would have been more noticeable in the following season after the biomass broke down. The next parameter we looked at was infiltration rate, which measures how fast water perks into the soil. We drove 5 of the 4x4 bulk density tools 2 inches into the soil and filled them to the brim with water. After 15 minutes, we measured how far the water level had gone down in the tube. Just like the bulk density data, infiltration data is also highly variable, so the median value was used for each plot. The week 3 data is a great indication of the level of variability. One apparatus had no noticeable infiltration after 15 minutes, while an adjacent apparatus had a very high infiltration rate. Overall, there really was no pattern to the data, with the youngest plots having similar infiltration rates as the oldest plots, and both of these were similar to the control plots that had no cover crops. Infiltration is highly influenced by root channeling, since an empty root channel is essentially a pipe through the soil to move water and air. But when we measured the infiltration rates, these future channels were still occupied by the roots themselves, since they hadn't begun to break down. It's likely that higher infiltration rates would have been seen with the older cover crop plots in the following season once the roots had decomposed. Soil samples were also pulled and sent off to the lab for standard analysis to see if the length of cover crop growing season influenced soil nutrient levels. The farmer maintains his vegetable field at a very high nutrient level, so there were no differences seen in phosphorus, potassium, magnesium, or sulfur levels associated with cover crop length. Soil nitrogen levels are much more volatile. While the peas in the cover crop mix are legumes, the nitrogen levels of the soil didn't increase significantly in the year of the cover crop. Rather, we saw the highest nitrogen levels in the young cover crop plots and in the control plots. These high levels are probably more associated with rototilling than with cover cropping. Tilling the soil for either weed control or seedbed preparation drives oxygen into the soil. This flush of oxygen allows the soil microbes to break down the residual organic matter, which in turn releases nitrogen into the system. We would expect higher levels of nitrogen associated with cover crops to be more noticeable in the following season when the crops break down. The lab data didn't indicate any association between pH, cation exchange capacity, or organic matter levels with the weeks of cover crop growth. This makes sense because it usually takes a long time to change these soil measures. Overall, the biggest benefit we saw in the year of cover cropping was the protection of the soil from wind and water erosion. In the following spring, we went back to the plots to evaluate the level of soil coverage provided by the cover crop through the winter. Here's the level of residue we see in the 1-week-old plot, 2-week-old plot, 3 weeks old, 4 weeks old, 5 weeks old, 6 weeks old, 7 weeks old, 8 weeks old, 9 weeks old, 10 weeks old, 11 weeks old, 12 weeks old, 13 weeks old, and the plot with 14 weeks of growth. In comparison, here's the control plot with no cover crop planted. The farmer was pleased with the level of erosion protection he got over the winter. He did mention that the older, high-residue plots had to be disked twice in the spring instead of his usual single disking in order to prepare the field for potato planting. So, what did we learn from this weekly cover crop planting project? First, irrigation influences germination. If you don't have adequate soil moisture for germination, the cover crop seed is just going to sit there. In a mixture of cover crop species, herbicide options may be very limited. If you need to use an herbicide to go after a weed issue, you'll probably also impact some of the species in the cover crop mixture. Likewise, if you use mechanical means to control the weed, you may also reduce the potential benefits from the cover crop. With the warm fall season that we had that year, adequate soil cover for erosion protection was attained in only 4 weeks of growth. In the following season, a cooler fall, it took 5 weeks of growth to get adequate cover. Excessive levels of residue may influence both the soil temperature in the spring and the level of tillage necessary for seedbed preparation. Some of the known soil improvement benefits associated with cover cropping were not seen in the year of planting. This is probably due to the cover crop still being intact when we measured the various soil parameters. Overall, we think it's a very feasible strategy to immediately plant a cover crop following the harvest of early and mid-season crops in the Matanuska Valley of Alaska. I'd like to thank my colleagues at the USDA Natural Resource Conservation Service for their assistance in this trial and also for sponsoring it.